Okay, so now I'm going to introduce you to how to make a basic orthographic drawing. Now, instead of showing the front, top and side of an orthographic drawing, we are going to focus just on the front today. Just to give you an example of where this is used, so this is used within engineering, this is used within architecture as well. It is a plan of what you are going to make, and it is done to a certain scale. The scale that we're going to be using is 1:1, which means that for every 1 centimetre or even 1 millimetre, it means 1 centimetre or 1 millimetre in real life. So for example, in year 10 and 11, we have been tasked with designing a phone holder that attaches to a rig. So here is a design of one of those phone holders. So as you can see, here is the 3D. This is just a concept showing you exactly how it works. Now this is in isometric. So a 3D object, you can see absolutely everything, the front, the side, the back, and so on. Now an orthographic is a 3D sketch in a 2D format. So it shows you everything. So the front, the top, the side, almost every part of the product, but in a 2D format. So as you can see here, this is 3D. What we then did was produce an orthographic drawing or technical drawing, they are also known as, for each part. So you can see here, so this is part 1. Part 1 is just at the bottom here. This is part 2, and you can see all the lines are in. So this is the front, this is the top of that part, and that's the side there. You can see that part there. Part 3, 4, and 5, which is the telescopic design that you see here. You've got 3, 4, 5, and this is it to its exact dimensions. Now, if I bring this a little bit closer, you can see that I have said that this is 20 millimeters wide, 15 millimeters high. This has also a hidden feature, which I'll talk about in a second. Now, from the top, it would look like a ring. So the diameter of that circle is 20, meaning that the radius is 10. And the inside of this, the diameter of the inside of this one is 15, therefore the radius is 7.5. The same thing has been done for this part here, which is part 6, which you can see here. There is a hidden feature behind this, and it's shown in its entirety there. That would then be delivered to a factory. The engineers would look at this and they will be able to build the product to exact the size that you want it to be using the materials that you have stated for them to make it out of as well. Now, like I said earlier, we are only going to focus on the front side of our orthographic drawing. So just to let you know what you're making your prototype clock out of, you are going to get a piece of 15 by 15 card. So this is 150 mil by 150 mil, and that's going to be the size of the back of your clock. So the main face is going to fit within this. So if it is 15 by 15, the first thing we need to do is draw a box in here anywhere on this grid at 15 by 15. Now, if you feel more comfortable drawing it at landscape, you go ahead and do that. Whatever works for you. I'm going to do mine in portrait. So using a ruler, and everybody should have a 15 centimeter ruler with them, all I'm going to do is mark the corner here, count up to 15, and 15 lands just on that line, and this is my starting point. So I'm going to draw the line across, following that guideline that I do have here, across like so, and that's my first part. I am then going to go 15 centimeters down, or 150 millimeters down, because that's what it is on the side. So I'm going to go here, go to 150, and I'm going to bring it right down to this line here, like so. I have then got another 15 centimeters to go, so I'm going to go across, like so. And I'm going to join these together. Now that is your 15 by 15 card that would fit perfectly in there. Okay, so the teacher's now going to pause the video and you are going to draw this 15 by 15 box in your or on your orthographic page. Okay, you should now all have a 15 centimeter by 15 centimeter square on this page. Now, what's important with orthographic drawing is that we provide the engineer or architect with as much information as possible. So to be able to tell them that this is 150 millimeters or 15 centimeters, all we're going to do is just draw a little line, and then using our pens, I am going to write down 150, showing that the length of that is 150. Coming down here, same thing here, 150, and that is now enough information for the engineer to understand, right, whatever piece this is made out of, it is going to be 150 millimeters by 150 millimeters, or 15 centimeters by 15 centimeters. The next part for our clock is to figure out where we're actually going to put the mechanism. Now, the mechanism is what makes the clock move. You usually have this in the center, and we're not going to change that format. Even though it could work anywhere else on the card, we are going to try and put the mechanism right at the middle. So the first thing we are going to do, and the easiest way to find the center of a box or a square, is to draw a light line from corner to corner. So I'm going to go here, draw a light line from corner to corner. And wherever those two lines meet in the middle there, that is the center of your clock. Which means if you have a clock at hand, luckily I have one here hidden in my pocket, that is the center of the clock. Therefore, that point there is where that is going to be. Now, I'm going to pause this video. The teacher's also going to pause it for you to put this cross in. Should not take you more than 10 seconds. Okay, right. Now we know where the center is. Now what we need to do is to imagine that we have the mechanism inside this already. Okay, now by mechanism, what I mean is the motor that actually gets this to turn round. So if we turn the clock around, we can see the mechanism there. So that's the size of this. Now, as you can see from this, at the front of the clock, you can't actually see the mechanism at all. It is completely hidden. It is a hidden feature. At the back, you can see it. Therefore, it's not a hidden feature anymore. However, if we are doing the front face of this orthographic drawing, we need to make sure that we show where the hidden feature is. So the first thing I'm going to tell you is this. The size of the mechanism that you will be using will be roughly the same size as this. So that's 55 millimeters by 55 millimeters. What that means is that that has to be absolutely center here. So what I am going to do now is draw a box here showing a hidden feature. And this is the way I'm going to do it. So I've already said that it is 55 millimeters by 55 millimeters. Okay, or if you want to use centimeters, we usually use millimeters in engineering, but for this purpose, if you find it a little bit easier to use centimeters, you use centimeters. So 55 by 55. What I now need to figure out is what is half of 55. So half of 55 is, come on, Mr. Thomas, quick maths. There we go, 27.5. So I'm going to place my ruler on 27.5 millimeters, which is just there. And I'm going to put a little line here. Then I'm going to take that to 55. Done. Okay, so now I know that's 27.5 millimeters, 27.5 millimeters. So if I use this ruler here, it'll show me 55 millimeters. I am then going to turn this around and do exactly the same here. And I'm going to go from 27.5 millimeters to 55 there. And all I'm going to do now, nice and light, I'm not going to even bother measuring this. I'm just going to do nice and light lines all the way across those lines that I've just done. Like so. And there I have the exact size for that hidden feature. Now, as I said, you are not going to see it if we're doing the front. You are not going to see it. You do not see that mechanism at all. So what we're going to do, instead of having a solid line, and I'm going to use a pen to show you this, just so it's clearer for you. Instead of having a solid line that shows this mechanism, we are going to have a dashed line. What that shows to the engineer is there is a hidden feature behind this clock face, this size. So I'm just following that line all the way around. Showing to the engineer that whatever's there has to be hidden. You will not see that at the front. So if your clock is smaller than that, you would see the mechanism. We need to cover that mechanism up. Right, the teacher's now going to pause the video and you are going to draw this. Now remember, it's 55 millimeters by 55 millimeters, or 5.5 by 5.5 centimeters. Do that now, please.